Hey guys, let's get started. So today's lecture, I wanted to keep it simple and I want to explain you something which is very basic, very basic. Think about it. So let's say that today I want to run a very basic program. Let's say that I want to run this, include stdio.h and int main followed by return 0. Or let's say that I just print some hello world program for this thing, right? I write a hello world. So although it seems very basic, but in college time we might have spent a lot of time to understand about this very basic thing, right? Nothing fancy, nothing changes, but behind the scene actually a lot of things actually go right, just to understand how things actually work, right? It's just not a simple hello world program. So this is why I stress that the fundamentals are very important over here, and people actually have a very little understanding about it, right? So that this is the reason I started to make a video series or maybe some videos to explain you more about the very basic fundamental, which is present, but people actually do not put a stress on these things, right? So let's get started. You write this program, you can write, and you save it with some name. Let's say that I save it with my name, aniket.c. Then you compile it, right? These are the basic steps which you do. Then you run the program. Then you when you run the program, the OS loads the program actually. So it's just not a simple run. It's the OS loads it using xcvc, and the memory is set up and CPU starts executing main. So this is how I differentiate between a college kid and a person who knows like how does the program runs, right? You might just say that key I save it as aniket.c, I compile it and you run the program, right? But a good person will cover up these three very basic things, that the OS loads it up, memory has to be set up, and then only then CPU starts executing it, right? Think about it. You might even come over here and say that when you basically think about कि तुम गेम चला रहे हो, बस तुमने गेम पे क्लिक किया and it starts running, right? That you skip over all of the fundamentals, that how actually the operating system loads it, right? And let's say that you even told that okay, operating system somehow load this given program which is present over here, but loading is not simple, right? It's just not a simple loading. मतलब ऐसा तो नहीं है कि this thing will be saved somewhere in your disk, right? And eventually, as you know, that you will be playing or sorry, you will be running this program from the main memory, which is your RAM memory, right? So the memory has to be set up, right? And if the memory has to be set up, then write instruction has to be put in that memory, right? And only then, only once the memory setup has been completed, only then the CPU starts executing the main program, right? So these are the very basic things which is present, right? But people actually do not put a lot of stress on it. Why? Because they feel like theek hai, basic hai, who cares about it? But there is a lot of things, right? So again, how do you compile it? Just you run the gcc.aniket.c and you run aniket. Right? This is how you compile it. How do you run it? You basically type aniket dot slash aniket, whatever your name which you have provided over here. If you have not provided any name, so it will be something like a dot out, right? It will be provided with something like a dot out. Yep. And how do you so after this, although all of these things are taken care by the operating systems itself, but these are something which you need to know about, right? So let's I will not go down to the saving the file dude. Because saving the file is something which comes under the file systems of the Linux kernel itself. So it's let's not go over there right now for this thing. Let's talk about the step two itself. But it's a good video which we can make about, right? So in the step two, what can eventually happen is that the first phase, as you might know, is the pre-processing phase. Pre-processing, right? So what happens in the pre-processing, right? So we might have supplied some we might have include some external libraries over here, right? And we might have some macros which is present over here, right? There might be some macro, let's say that text 500. So this is one of the macro which is present actually. And since this is one of the macro present, we need to this macro has to be this will be eventually used somewhere in the code, right? Let's say that I would have done certain operation. Let's say that int x is equal to 10 plus text. So this is one of the operation which I might have done as part of this program, right? So eventually someone has to do the replacement work, right? Someone has to do the all the fancy things which we have done to define a macro. Someone has to come ahead, replace this thing with some correct value, right? So that later stage when the program starts running, it does not have to check, oh, what does this text corresponds to, right? It can directly see that key someone has already done the heavy load of taking this text and replacing the actual value over here. Something which is very simple but no one talks about. So one of the another thing is that I will come to this part only also, that how does the preprocessor expands the stdio.h, right? But that is something which I will come later on this part, right? So since we are very clear about the pre-processing part, we can move ahead to the compilation part, right? So we have compilation. So think about this. These are all C code, right? This is something which is written in the C code itself, right? This is not something which is think of it like it's not something, it's a human readable format, right? At the end of the day, it's a programming language, it's something you can understand, which you can write into, but it's something which not a computer will understand. And computer will never have the understanding of this thing, given thing, right? So what eventually happens is that we need to handle the so there comes the use of the compiler, right? So it converts the C code into assembly instruction, right? It takes the C code and converts it into a assembly instruction. So let's say we have a lot of different type of assembly instruction, like we have add, we have move, we have something around this, right? Sub, mul, and div, right? So these are the different kind of assembly instruction which we might have. At the end of the day, it's a game of same thing, right? It's a game of arithmetic operations, right? At the end of the day. So all of these operations is something which is done using the assembly instruction, right? So where the conversion happens, it happens as part of the compilation itself, right? But think about this. Think about this. Do you think computer will understand add? Do you think computer will understand move, sub, mul, div? No. These are nothing which computer can understand, right? These are again something which is in textual format. Think about this. The point at which you can't understand the code is something it is meant for computers. I mean, don't take it in a literal sense कि ठीक है तुमने मेरे को बहुत ही कोई heavy legacy code दे दिया, I can't understand it and it's meant for the computers. No, I don't mean by that. It's something which you cannot even read, right? Something which you cannot be. It's so what is that given thing, right? So binary thing. Computer understands only zeros and one, right? But these things also has some opcode associated to it, right? यहाँ पे भी सबका given value होगा. So for example, I could call this add with some opcode like 001, right? Not exactly 001, but something which you can take note of. 0 is 10, this can be 100, and this can be 101, 101, and this can be 111. Something like this. ठीक है? Now computers know that कि ठीक है, मेरे को एक ऐसा 001 का सिग्नल आया है, तो हो सकता है कि the person is trying to tell me to do the add operation. So it will do the add operation. हो सकता नहीं, होगा ही. So this is one of the basic thing, right? At the end of the day, someone has to do this job. Who does this job? You can take a pause over here and understand it. So the job is done by the assembly itself. So it converts the assembly to machine code. So ये जो machine code है ना, वो finally binary opcodes होंगे. So something like this. It finally converts into some binary opcode which the computers can understand, right? And finally, there is a linking phase. अब तुम पूछोगे भाई इतना सब होने के बाद लिंकिंग क्यों चाहिए? Think about this. This is very important part of the program. It its job is to देखो ऐसा लिंकिंग क्यों चाहिए मैं बता रहा हूँ. This is one of the very fundamental thing, ठीक है? You did the pre-processing, you did the compilation, you did the assembly level things, and so far so good, right? But this is a very small program. You might have different files. You might be working across different files, and in those different files, you will be working around understanding the code, and then you might be having some different inclusion, right? तुमने एक फाइल लिया, उसमें एक मॉड्यूल डाला, फिर दूसरे फाइल को कॉल किया, ठीक है? फिर ऐसे this could be a whole chain of things, right? And someone needs to take care of that, right? Right now we have not taken care anywhere something about this. हमने सिर्फ अभी मशीन बाइनरी कोड बनाया, ठीक है? लिंकिंग पार्ट नहीं किया हमने. So someone has to do it, and it is done as part of the compilation process. So the linker comes over here that combines your code with the required library code, like printf from libc basically, and it does one more job. It does one more job actually. Think about it. So you might have heard about this, that there are various memory section. ठीक है, हमने इधर बात किया था कि when we run this program, one of the job is that it also need to set up the memory itself over here, right? So the memory has to also be set up during this phase. So someone has to do the job, and you might have heard that there are different types of memory section, right? There are different types of memory section. Okay, so in your OS course, I'm not sure if you guys have know about this thing or not, but in your OS course you might have heard about the .exe section, right? So this is the place where our machine code instruction live, right? This is the eventually the place where a machine code instruction is eventually going to reside at. I will show you, don't worry about it, I will show you with some example that .exe दिखता कैसे है, ठीक है? Then we have a RO data which contains only read only data, ठीक है? So यहाँ पे एग्जाम्पल ले लो, स्ट्रिंग लिटरल्स के फॉर्मेट में कुछ होगा ऐसा, या तो फिर कांस्टेंट कांस्टेंट ग्लोबल, ठीक है? सो समथिंग लाइक दिस, राइट? बेसिक एग्जांपल चाहिए तो बस किसी को, अगर किसी को एग्जांपल्स के तौर पे समझना है तो फिर ये ऐसा समझ लो कि इफ यू हैव समथिंग लाइक कांस्टेंट कैरेक्टर मैसेज, देन this will be this thing will be called a so this thing is called a read RO data, not this thing. I will tell you why also this thing. Let me first finish it out, right? Then we have a dot data section. We have a writable global variables, variables that are initialized, right? And then we have a .bss section which contains writable but uninitialized or zero initialized data, right? So हमने चार important section की नाम याद रखना. First is a .txt, then is a RO data, then is a dot data, and then there is a BSS section, right? We discuss few of the things. देखो, अगर logically सोचोगे तो ठीक है. If I had to come up with this thing, okay, तुम सोचो कि इतना memory section की requirement क्यों है? हमेशा question चालू करो क्यों से. Then you will start making sense out of the things, right? So when you ask the basic question that why we need all of this thing, why can't we just have a single .txt? Why can't we just store everything to the txt itself? Now storing in the txt will we all engineering always starts with the simplicity. I'll tell you this thing. Engineering always starts with the simplicity. You always start doing the basic thing. You always start with a very basic thing until you hit a problem, right? Now, होगा क्या कि all the variables which is present over here as part of the .txt section. Think about this. If they are writable, they are writable. मतलब मैं ये इंडेक्स है, इसको कोई भी मॉडिफाई कर सकता है. बट हमने क्या सीखा है कि जो कुछ रीड ओनली डेटा है, तुम्हारे पास कुछ कांस्टेंट कैरेक्टर डेटा होता है, and these cannot be modified, right? So to enforce that thing, what you do is that you logically tell that there is a separate memory section called RO data, which is only meant to read, not write. Okay. Otherwise, what could have happened is that in the .txt only, you would have to write some logic to understand which are my .ro, which are my constant one, and I have to put a special check every time someone is trying to assess it. ठीक है? Makes things more complicated, right, at the end of the day. So उससे better है कि तुम एक separate section रख दो, .ro data makes my life more easier, right? And then we go ahead and then we talk about the dot data. ठीक है? These are initialized one. These are initialized one, and dot basis, these are something which is not initialized. Now again, it does not make any sense. तुम बोलोगे कि यार ये why do we even need these two things, right? Why can't we just say that कि dot txt के साथ ही हम इसको रख देते हैं? Let's just throw it over here and our problem is solved. But think about this, dude. Think about this. Again, if some other files or if there is some linkage, right, during the execution of the program, right? If you are referring any global variables, don't you think it's a more better idea that you store it very separately so that when you're trying to assess it, the assess becomes more faster, right? तुमने एक partition बना के रखा. Think about it as creating a logical. मतलब, if you want a better understanding, think about this that you have a single drive. I You have a single drive, and what you do is that you create four sections. First is where you can read and write. मतलब बोलते हैं प्लेग्राउंड है तुम्हारा ये प्लेग्राउंड टाइप. बट सीन क्या होता है कि when you're playing on the ground, you can always lose things. You can always lose track of the things, and searching for those things can make your life more hellish. So what you do is that you say that कि I define a section called dot data section. यहाँ पे तुमने एक मतलब तुम्हें बोला ड्राइव है, तुम्हारे पास हार्ड ड्राइव है ऐसा कुछ, ठीक है? तुमको उसको फॉर्मेट करना था. तुमने एक सी ड्राइव बनाया, एक डी ड्राइव बनाया, एक ई ड्राइव बनाया और एक एफ ड्राइव बनाया, ठीक है? ये सब लॉजिकल सेक्शन है एट द एंड ऑफ द डे. अब एक बात बताओ, जब मेरे को ये इनिशियलाइज और अनइनिशियलाइज की मैं बात करूंगा, बट जस्ट थिंक अबाउट इट. डोंट यू थिंक द वेरिएबल्स जो कुछ गेम्स के एसेस मेरे को जल्दी चाहिए, उसको मैं अगर डॉट डेटा में रखूं, मतलब डी ड्राइव में रखूं, डोंट यू थिंक द एसेस विल बिकम मोर फास्टर फॉर मी? बिकॉज नाउ आई डोंट हैव टू, आई नो कि मेरा जो गेम का डॉट ई एक्स है, ठीक है? आई एम जस्ट टेकिंग एन एग्जाम्पल ओवर हियर फॉर यू गाइस टू अंडरस्टैंड, टू मेक the sense out of this concept. But don't you think, guys, कि if my game is present in the format of game.exe, right, it would become more convenient for me to actually place it in a D drive so that if I want to assess it, मैं D drive खोलूंगा, मैं click करूंगा, मैं खेलूंगा, ठीक है? As simple as that. The assess becomes more simpler, right? And think about the game file is just an example. For us, the example is that we might have some int I is equal to 10, right? So when we define this stuff like these, right, what might eventually happen is that when we define stuff like this int I is equal to 10 becomes our global variable, and then we try to assess it, right? So assessing those kind of variable become very much easier for me. So because it already defined, I have created a separate logical section for it. But अब तुम पूछोगे यार तुमने BSS section क्यों बना दिया? Now this comes a very funny part, right? कभी कभार क्या होता है ना, कभी कभार क्या होता है, you know you want something and but you do not know how much you want it, right? It sounds very philosophical, but this is the ultimate truth. You know you want something, but you don't know how much you want it. So at that time, what we're gonna use is that we're gonna use a PSS section. But still लॉजिकल सेंस तो बनता नहीं है भाई इसका कुछ. बट एक बात बताओ, तुम्हारे पास एक array है, ठीक है? कुछ array है ऐसा, and array 1000 or maybe put a large number, है ना? Now think of it कि तुमने ये array define किया, ठीक है? And you need something big, like इतने तुम्हें 32 बिट के मतलब 4 बाइट के तुम्हें इतने एलिमेंट्स चाहिए. 4 बाइट इंटू ये कर लो कितना मैथ्स बनता है तुम देख लेना. बट द थिंग इज दैट कि when you know already what you want, you can pre-allocate the space. You can pre-allocate the space well in advance so that when you're trying to the when the memory is being set up over here, जब memory setup हो रहा है, you can easily assess and you can tell in advance कि मेरा requirement काफी huge है, तो तुम अपना उस हिसाब से सेटिंग कर लो. Think of it that before so, so think about this like this, okay? You went to a party, right? And तुमने एस्टिमेशन किया कि ठीक है, मेरे 1000 गेस्ट आने वाले हैं, तो मैं तुम 1000 खा मतलब प्लेट्स रखो, ठीक है? तो व्हेन यू ऑलरेडी नो दिस थिंग वेल इन एडवांस, दैट टाइम यू यूज़ द डॉट डेटा, ठीक है? ऐसा नहीं होना चाहिए कि तुमने बोल दिया कि यार मेरे को पता नहीं कि कितने गेस्ट आएँगे, जस्ट बी यू टेल द caterer that you just be prepared for that. Think about it, how disastrous that thing can be, ठीक है? How disastrous that thing can be. So that's why we have dot data section to help us with these things, right? I hope it कहानी यहाँ तक सेंस बन रही होगी, right? And then let's move ahead to the dot bss section. Now कभी कभार होता है कि actually we are hopeless, that कि भाई मेरा requirement ही clear नहीं है, right? So during those times we can use a dot bss over here, right? I just say that कि during the execution of the program, based on the user input, you can there is some global defined, and you can zero initialize it, right? But I do not know as of now how much is my requirement. So memory is allocated, memory is zero initialized, but and it's present as part of the bss section over here, right? So this is how the code works, right? And when you think about it, the final section, this is your ro data. यहाँ पे तुम्हारा कांस्टेंट लिटरल्स होता है, मतलब यहाँ पे थिंक अबाउट इट दैट कि दीज आर द थिंग्स यू व्हिच यू डू नॉट वांट टू बी टच ड्यूरिंग द एग्जीक्यूशन ऑफ योर प्रोग्राम, ठीक है? एंड इट्स वेरी इंपॉर्टेंट बिकॉज people can tamper things, people can play around with things, and they can become messier. So when we look at the final memory section, it looks something like this, right? When we look at memory at runtime in a simplified format, it's something like this. So first we have a stack, then we have shared libraries, then we have one heap, then we have data segment, which contains the dot data and dot bss. Then we have text segment over here, which contains our dot txt, dot ro data, and finally some lower addresses. यहाँ पे कुछ lower addresses हो गए. I don't know what is there. So I think so far so good, and I have not explained to you what is the use of this stack and heap, right? So during the function call, right, uh, during the function execution, all of the variables which is present is part of the stack, right? And when you do a malloc call, right, at the end of the day, when you have to allocate some memory to perform certain operation, that time the memory gets allocated from the heap itself. Now I will ask you one simple question, right? I will ask you one simple question because I love playing with things. So let's say that this is a stack and this is our heap, right? So as you might already know, they grow in the opposite direction, right? Stack, if you talk about it, it starts to grow downward direction, and heap, when you talk about it, grows in the upward direction. Tell me this, why they are not growing somewhere separately, like stack भी हमने एक रीजन क्यों नहीं डिफाइन कर दिया stack के लिए, heap के लिए, and why don't they grow like this, right? So when you try to engineer these things, these are the very basic things जहाँ पे differentiating factor आ जाता है. अब अगर तुम ये ऐसा कर रहे हो, तो then what might eventually happen is that no problem, okay, I just say कि ठीक है, I will add some lump sum fees over here, and then I will see about it, right? So what eventually happen is that when stack has only grown this much and the heap has only grown this much, my this much pre-allocated space will go for a toss. ठीक है? So this causes, if the stack and heap grows both in the downward direction, what might eventually happen is that there is a loss of space. I'm not being a very memory efficient person over here. So that time we want to avoid all of this thing, and we allow the stack to be growing in a downward direction. And for the heap we see that कि ठीक है, अगर stack ने इतना grow किया है, तो minimum अगर heap इतना use करे तो ठीक है, इतना use करो, कोई दिक्कत नहीं है. So at the end of the day, using this operation, I become more memory efficient, right? I will talk about in some later video. I might talk about the stack overflow, how does the heap allocation take place, but I have written few articles and you might be interested in how these things works eventually, right? So I think so far so good, right? So far so good, because we have discovered a lot of things up till here, right? We discovered that how the .ext section works, how these section works, how the load happens, right? So compilation phase, assembly, linking, I think so. We have pretty much covered all of these things, right? But let's go. एक काम करते हैं. Let's go ahead and see these things live because the fun begins over here. So let's say that I write Aniket.c. Eventually, it won't take me much time. Oh, it's slow. It's fast now. No. Anyways, it's not a big program which I'm writing eventually. So sometimes things are very basic in life, you know. But भाई ये क्या हो गया? When you don't know what's happening in Vim, right? Just do this. So yeah, अभी मेरे को इसको run करने दो, right? And let's try to run this thing, right? So we can see that hello world print हो गया. काफी basic सा लग रहा है. But I want to look at how the preprocessor actually works, right? So let's say that I do the use the GCC flag for this Aniket.c and I output this in Aniket.I, right? So when I look in the LSI, so I can see that there is a Aniket.I which eventually gets created. And let's look at the content over here, right? So if you look at the contents, you can see that कि जो मैं बात कर रहा था pre-processing phase में, है ना? भाई साहब. So मैं बात कर रहा था pre-processing phase में. Eventually all of these things get replaced, right? ठीक है, ये तुम्हारा library call था जो आपने stdio.h call किया था. Eventually all the replacement which happens as part of it gets replaced in the processing stage. And इतना कुछ रायता फैल जाता है. बट यू कैन इवेंचुअली सी दैट यहाँ पे अगर मैं printf सर्च करूँ, हो पाएगा? हाँ, यहाँ पे printf हो पाएगा ना भाई? कहीं पे तो होगा ना यार. ठीक है, यहाँ यहीं पे कहीं होगा printf. इन डी printf है. हमारा printf भैया कहाँ है? There is a printf dude. कहीं से हाँ, ये रहा printf. So eventually you can see that uh, this will handle a printf function call, and eventually hello world will be displayed on the output terminal itself over here, right? So one more thing which I wanted to show you actually, but I cannot show you, is that as part of your pre-processing phase now, एक और चीज होता है कि I think so I've not mentioned it over here guys, but I think so it's very obvious that your macro gets replaced. No one cares. Computer don't care about your comment. And finally, the library replacement happens as part of it. Yep. So far good, right? Now after this, let's move ahead to the compilation phase. ठीक है, compilation phase में जाके देखेंगे कि finally assembly language कैसे generate हो रहा है. ठीक है. So again, it's a very interesting thing, right? So when we do this thing, gcc.aniket.I, and we take this pre-processed file and we finally convert it to some assembly instruction. You can eventually see, you can use these commands too, and S stands for the assembly itself. So I will use this Aniket. मैं फिर से इतना रायता नहीं दिखाना चाहता हूँ आपको, तो let's just use this ls dot. So eventually you can see over here is that कि sorry. So eventually you can see over here is that कि जो मैं बोल रहा था ना कि assembly language रहता है, the move queue, push queue, all of these things call, and all of these things get replaced over here, right? And your C code is not present anymore at the end of the day. तुम्हारा हेलो वर्ल्ड कहाँ है? यहाँ पे है भाई, यहाँ पे तुम्हारा देखो स्ट्रिंग के फॉर्मेट पे इसको रखा हुआ है इसको उधर. ठीक है. I'll come to that, but eventually don't ask me dude how these run. These are made by the people who are more मान के चलो कि it was made 30-40 years back in time, and that time it was pretty interesting, right? Nowadays we engineers don't care about this thing, but even to construct this basic thing, it will just eat the, like it will take lot from you. It's a heavy engineering. It's just not a simple thing, right? So yeah, as you can see, it contains all the assembly instructions over here, and it's pretty fun to watch these things running, right? let's just end it. And so I had told you about कि देखो, एक बार जब तुम्हारा assembly हो गया, when your assembly gets converted, then sorry, the compilation gets completed, then your assembly happens that converts the assembly into a machine code. That is the binary out opcode, right? So let's understand how this happens. So for even this, we have a command gcc.aniket.s. अभी यहाँ पर s लेंगे, उसको फिर o में कन्वर्ट कर देंगे, बेसिकली जो फाइनल स्टेप का लिंक करका था, ठीक है? तो यहाँ पे देखना, there is some warning, don't worry about it. So eventually you can eventually you can inspect it, right? Yeah. अबे यार, yes, हाँ, ये अरे ये बाइनरी दिखेगा नहीं तुम्हें फिर, तो देखते हैं यार बाइनरी कैसे दिख सकता है। आई थिंक सो इससे दिख सकता था क्या? नहीं यार, आई थिंक दिस इज इन बाइनरी, सो दैट्स व्हाई यू कैन नॉट व्यू इट। लेट मी सी। ओके, ऑब्जेक्ट डंप करते हैं इसमें भाई, मैं भी क्या डम इंसान हूँ। इस पे ऑब्जेक्ट डंप करो जब भी बाइनरी सब देखना हो ना, तो मैं ज़्यादा सोचो मत, do an object term, otherwise the symbol interpretation will not be something which you can see. So eventually जो मैं बाइनरी की बात कर रहा था ना, कि these are the main function की बाइनरीज, ठीक है, जो push, move, load, call, pop, all of these things are done as part of the binary itself, right? And the final phase is the linking phase. So linking phase में होता है क्या कि it combines the अनिकेत डॉट, ये तो एक ऑब्जेक्ट, ये तो एक डॉट ओ फाइल जनरेटेड है, राइट? एंड एट द एंड ऑफ द डे ये सबको कंबाइन करके एक अनिकेत, एक एक प्रोग्राम बना देगा उसको, ठीक है? फाइनली एक प्रोग्राम अपने पास रेडी होगा, एंड इफ यू वांट टू रीड, सो जो लिंकर रहेगा, जो फाइनल स्टेप में जो लिंकर होगा, right, which I specified over here, you can see that key it combines the code from the various required library code, right, and it generates all the memory sections for this thing and ensures the placement happens accordingly for that. So let's go ahead and understand this thing. So linker का ELF file है जो executable format है, so you can eventually see this thing, right? So this is the header. It tells you the किस Unix version पे मैंने बनाया था, किस ये architecture के regarding है, start of the program header, ठीक है, start of the section headers, the program memory section headers, right? And ये सब basically मान लो कि ये तुम्हारा metadata है, this is a magic number to ensure that this is not being tampered across, right? And finally, let's deal about the ELF for the let's talk about the program header, right? In the program header, you can clearly see that there are different sections as part of it, right? So अभी तुमको लग रहा रहेगा भाई ये सब क्या है? And to be honest, this was my first reaction too, कि भाई ये सब है क्या? But trust me out, these are very interesting facts, like you know. So just to give gist about it, this is mostly related to the GNU wala side taken out, and something even I'm not sure about. It can be used later in the file for the program header itself. You can feel free to explore these things, dude. You just feel free to explore all of these things and get back, because stay curious, stay hungry. That's the thing, right? So I just spend some time to deep dive, dig deep in that and understand more about it, right? And finally, let's understand the read ELF thing, right? Let's understand the section which we were talking about, right? These are the section which we are interested about, right? So again, these are places you can find your RO data, you can find your data.bss, right? And .bss हो गया, RO data हो गया, data, और एक और था ना भाई, क्या था वो? .ext कहाँ गया अपना? txt, txt नहीं है क्या भाई इसमें? हाँ है ना, txt, इधर है txt, sorry. So eventually you can see all of these things get eventually created, and बट तुम्हें जब कॉलेज में सिखाते हैं कि भाई 4 ही सेक्शन होते हैं, नहीं भाई 4 सेक्शन होते हैं, बट उसके बाद भी कुछ सेक्शंस होते हैं, एंड यू नीड टू केयर अबाउट दीस सेक्शंस, राइट? बिकॉज कुछ सेक्शंस मेरे को इंटरेस्टिंग लगा, जैसे कि जेएनयू हैश करके एक सेक्शन होगा जिसके बारे में पढ़ रहा था, एंड इट गिव्स यू द इंफॉर्मेशन दैट सम फास्ट सिंबल्स which it eventually wants to load, right? Then there is a dyn cm section. Dyn cm section कहाँ रहेगा, रहेगा क्या इधर? I was just reading it dude, somewhere कहीं तो रहेगा, पर अभी इसमें सर्च करने में मेरे पास टाइम नहीं है. So Dines, so yeah, couple of these things are present, right? And when we talk about, let's actually take something and talk about. So okay, let's start with the init one, right? So init one में आपका basically before your main function gets executed, there is some small function which eventually gets generated by the compiler. So this is done as part of the init process, right? So it can be used by the compiler for the static constructor in the C++ itself, right? That is one thing. So उसको बोलते हैं procedure linkage table. So now एक ये हो गया तुम्हारे पास, and again these are all related to the procedure. यहाँ पे तुम्हारा text section, जहाँ पे हम लोग ने जो text section दिखाया था, it eventually goes over here and sits, and then you have fini section. So this is a place, the function which gets executed before the main, like sorry, function after the main, like जो भी just like an in it but at shutdown, ठीक है? So just like make sure that the when you're executing the program, just put some good values or something around that, right? Again, feel free to explore these things. It's just all left to you. हमने आरओ डेटा तो ऑलरेडी डिस्कस किया था, ठीक है? बाकी ये EH मतलब एक्सेप्शन हैंडलिंग मेटा डेटा है ना, फॉर द स्टैक अनवाइंडिंग, एक्सेप्शन हैंडलिंग, debugging. So even GCC generate these back traces and cleanups, right? Just to note. So finally we have init array and fini array. So this plays a crucial role in C++ because कभी कभार क्या होता है ना कि there are some function pointer that must run before main, right? So जो static constructors है उसके लिए use कर सकते हैं इसको, है ना? And fini मतलब कि it's run at the end, like जब program खत्म हो जाता है तो it's just here the function to run on exit. So that's pretty much about it, right? Right, and finally we have a dynamic one. So dynamic may some tables are there. I don't know what they are, but again, feel free to explore. Again, there is a global linkage table. Then we have data, bass, those things which I have already explained about. Compiler version string. Then we have मैं बोल क्यों रहा हूँ कि मेरे साइड में थोड़ी नोट्स हैं, मैं उसको रेफर करके एक बार शो कर रहा था, ठीक है? तो pretty fun, right? I don't want you to overwhelm you guys at the very start itself, right? These are the basic things which you should have explored. If not a worry if you have not explored, right? So and for the homework, what you can eventually take is that ki, when the program is running, right, you can see the runtime memory mapping for a running process, and वो तुम cat से कर सकते हो, pmap से कर सकते हो, right? You can even explore the function trees for the XCV. जब तुम ये सब जो भी call mmap call होते हैं उसके तुम function trees explore कर सकते हो, and inspect the dynamic dependency as well. So these are the different things which you can explore as part of the things, right? So hope this video was fun. I think so. Yeah, that pretty much covers about it, right? So eventually हुआ क्या कि जब मैंने program run किया ना, right? I just want you to cover on that topic. When we run the program, we might have some XC. So we might be running on the X shell. Shell will perform a system call because eventually एक XCV करके command रहता है, ठीक है? This is your path to program, and we have our GV, and eventually when kernel passes the ELF program header to the all that operation happens, you know, the kernel sets up the. So when above call gets executed, the system call, right? So after this, kernel will read the ELF header, and it will check the offside memory size permission .txt, and वो सब करेगा kernel. उसके बाद the kernel sets up fresh address space for the process and use the जो मेमोरी एलोकेशन बेसिकली बाद में होता है वो mmap से होता है, वो मेरे एक आर्टिकल से है, मैं थोड़ा बहुत लिखा उसके रिगार्डिंग, बट तुम देख लेना उसको बाद में, ठीक है? जरूरत नहीं है फिलहाल के, क्योंकि हमने काफी कुछ इंटरेस्टिंग फैक्ट्स एक्सप्लोर किए हैं, बट इफ आई हैव टू रीडू माय इंजीनियरिंग, दिस वुड हाउ आई वुड हैव इवेंचुअली डन माय engineering, correct? And I hope it makes sense to you guys. So yeah, so far so good. So thank you guys, I hope you like it.